Hello, class. Welcome to Big Bang Data Science Solutions, week number 6, session number 2. This is the free program that we started in Ramadan a few weeks ago. And we are still in the process of understanding the steps required to prepare and pre-process a data for an analysis. Of course, why do we need to prepare the data? To avoid the GIGO things, garbage in, garbage out. To avoid, of course, the biasing and the deviation from the truth, from the reality. So in data preparation, we learned how to do a couple of things, how to binarize. We talked about binarization, normalization, discretization. And yesterday we talked about a couple of transformation methods, especially for to transform a skewed data to nearly unskewed data. So today we are going to talk about. Then we talked about the missing values, outliers, and today we are going to talk about another topic, which is the categorical data. Most of the algorithms that you will have to deal with in the future, they are algebraic or probabilistic models that require your data to be in a certain shape or they require certain assumptions within your data, especially they require numeric data rather than categorical data. Some algorithms, they really don't care if you have categorical data or numerical data. They really don't care if you have missing values or outliers, but there are very few algorithms, and their performance or their accuracy might not be up to your expectation. And we are naming here random forest, decision tree, bagging, boosting, and any algorithm that uses decision tree as the base learner. Okay, so in the previous sessions, so we imported the three most common packages: NumPy, Matplotlib, and Pandas, numerical Python, data visualization, data manipulation and analysis, and data visualization. Then we imported our version number 2 dataset. Version number 2 is simply version number 1, and less some of the features that we thought that we determined not to include, either using prior knowledge or using correlation analysis. Then we apply some generic functions to help us determine the values and the importance of the values. We apply describe. Describe is used to generate the 5-number summary of your data. So look through them and see if you have any, if there is any suspicious numbers, especially the zeros, the empty zeros, or negative values. Then we moved into how to determine a missing value using the missing no package, and of course using the also using the using the asum function. But if you have a missing values, they should be detected either using the missingness library. It's a visualization library that detects the location or the position of a missing value within your data, if any. And then we learned how to handle these missing values, either by dropping them all or by dropping a column, replacing the NA, the missing values with none, with NA. And also we learned how to we could impute missing values using the mean, mode, median. Mean and median, they are for numerical data, and the mode is for numerical data. Then, or we could use we could split base split on the most common feature with the highest missing values, and use that as a target variable to predict the value of these missing values. And when we are using prediction, we could use Miss Forest implementation, something that we experienced yesterday, or we could use the k-nearest neighbor. Um, I heard or I read somewhere that the missing for forest, which uses the random forest library or package, I'm sorry, which uses a random forest algorithm, is better, to determine the value of missing values. So then we talked about missing the outliers using grabs test as a method to determine the value, to determine the outliers. Then we learned how to visualize, or using box plot to visualize the outliers. And we learned how to calculate the IQR and remove the missing values using IQR. I'm sorry, removing the outliers using the IQR. Also, we learned how to compare the normality of a feature with its distribution. And of course, it's a great lot of information in terms of how closer a distribution of a feature to its normality. And then we learned how to use z-score to determine outliers. This score is a range between -3, 3 and -3. So if you apply this score on any feature, if you have a value greater than 3 or less than -3, that is an indicator that you have an outlier in that feature. And we talked about the numerical transformation. Especially we talked about the skewed numerical data, how to transform it. If it's positive, we could use square root transformation, or reciprocal transformation, or log transformation. And of course, if it's negative, we could use the square. No, we change the power. We start from 2, 3, 4, and we augmenting based on the improvement of the skewness of the variable you're trying to fix. Then boxcox is another method to transform the skew data. Then we talked about in brief about other conversion, data discretization, binarization, boxcox transformation, how to convert a string. Means this is the code that you could. If you have a string, you want to convert it to an integer. This is the code. Then we learned about how to scale. Scaling is an important feature, an important concept in data science. And why do we need to scale? Simply to avoid to avoid having some variables dominating over others, especially large, having the features with larger values dominating over features with small values. So then you will create some biasing. Then there are many methods, scale to 0 and 1, -1 and 1, -3 and 3, normalize, standardize, min max scalar, etc. And of course, this is not an exhausted list of the scaling method that you could use. Okay. So again, we spent enough time to understand, build skills to help us understand the data, understand the decision. Then we spent quite a bit time to help us acquire skills to understand the data and build the quality book. Then we use the quality book that we determined to prepare and preprocess data. So in brief, we talked about normalization, factorization, binarization, standardization. We learned about correlation analysis. We learned about the aggregation. We looked into missing values, outliers. We talked about target variable. We talked about the duplicate and redundant data. And we talked about transformation yesterday. Today we are going to talk about data conversion, especially categorical data to numerical data, and we'll talk about feature selections. These are some of the two concepts that we are going to learn today. And hopefully, towards the end of today's session, we should have a ready to go, a better version of the data compared to the raw data or the raw version that we started with. And this is the version we are gonna use for next week to start building some models. Any question, concern, any doubt before we dive deep into today's topic?
Well, I have a question.
Yes, sir.
We have learned a lot of techniques for data cleaning, and should we, as a beginner, stick to one method so we could get better rather than learning all of them? I'm just asking for suggestion because they're all a little bit different.
Unfortunately, unfortunately, that might not be the case. You should try to learn as many as possible. Why is that? Because one method might not be the right method. Number one. Number two, there is a concept in data science. It's called no freelance theorem. It's in the helicopter view. It's simply what works for you for a certain problem, certain data might not work for you all the time. So if you are familiar with discretization, for example, if you know how to discretize your data, and for a reason it might not work, it might not work for any other problems. If you know how to normalize, probably normalization might not be a better solution for a future data. So your job as data scientist is to keep trying combination of these methods until you got a better model, a better accuracy. At the end of the day, all we care about is the return of an investment. So to maximize the return of an investment of the project that you're working on, so you have to feed into your model a data that has been 100% clear. And to do that, you got to try. You need to try normalization. It might not work. Try standardization. Might not work. Convert your categorical into a numerical using a certain method. Method A might not work. Try method B. Try method C until you find something that works better for you. So now in one direction will not get you. It could be the right direction, but for a certain business problems and a certain data set. So you have to try. You have to learn as many methods as possible. Okay, Navid.
Yeah, I got it. No, I was more trying to understand different ways of doing the same thing. Like for example,
Yeah,
finding outliers.
you might think they are doing the same thing, but mathematically they are not doing. They are not using the same mathematical equation, mathematical
Hmm.
function.
Okay, so one may give you different value than the other,
Yes, sir.
and you need to pick the better one. Okay,
How do you pick the better one? Is trying.
experience, yeah.
Yes, you need to try them and keep trying. And unfortunately, in your real life scenario, 80%, 80% or plus, 80% plus of your time would be spent from the three bullets in here: business understanding, data preparation. When I first started my journey, I thought the most complicated part of the entire journey is the modeling, but modeling is a piece of cake. Yeah, I mean, three lines of code, you could build a model. Only 3 lines of codes, which we are going to learn next week. So your 70%, 80% and plus is in a foundation. If you misunderstood your business problem and your data, and if you misunderstood the data, of course, you are going to use a wrong transformation method, which of course will impact a return of investment. So spend as much time as you can and the three blue bullets here to help you prepare the best version of your data. Don't panic if you feel like you are falling behind. And most of the project that I worked on, in one of them, the last project that I worked on, it's a 6 months project, almost 5 months. 5 months spent in business understanding, data preparation, and 1 month in testing, building a model, optimizing the model, testing, and deployment. So that is the way. That is the real live scenario. Okay,
Um,
so yes.
one quick question. Sorry, I don't want to take too much time. Are there really we should adopt some kind of best practice in terms of data cleaning? That first we apply the prior knowledge, eliminate the columns that either provide the constant value, or apply the correlation, apply or remove the outlier first. Is there a best practice what we should follow? I know we learn all of
Unfortunately,
these.
yeah, it could be, but unfortunately, as I said, no freelance theorem, no, might not work. So yes, I mean, what you see here is not the right. It could be the right order for a problem, by no maybe it might not be the right order for a second problem. So your job as data scientist is to explore possible ways of handling your data. Just keep trying. Keep torturing your data until it confuses to something. We don't know what do we have in the data, and we don't know which is the best possible optimal method of handling your data. Unless you tried A and B, you don't know if it's A is better than B, and vice versa. So there is no don't think that way. Now your job as data scientist is number one, to understand the concept, understand the flow, and keep trying until you get something meaningful, until you get something that makes sense. Okay.
Okay, thanks.
Yeah, welcome. Any other questions, concerns, please? Everybody, please speak up. Okay, so now we are going to talk about data conversion, or converting categorical data into numeric. So this is our version number 2. And as you see here, we got a lot of features that they are numeric, so categorical. So they are categorical in here. So all this, they could have some insight or some importance. So before you think about transforming your categorical data into numerical data, a few things that you need to know, that you need to figure out. Few things that you need to figure out. Number one, you need to figure out if no, you need to figure out the type of categorical data that you have, and the level of granularity, or level of cardinality. That is two things that you need to determine as data scientist. Okay. To handle again categorical data, you need to know two things about your data, about your categorical data. Go number one, type of categorical data. Number two, level of cardinality. Okay, and of course we already learned a lot of generic methods to help us understand the type of categorical data and level of cardinality. So why do we need okay, how many types of categorical data you know? You know? Any thought?
Yes, no.
What do you call that?
Boolean.
Boolean would be true, false, correct?
It's like binary. Yeah.
No, there is no binary, brother.
Oh.
Categorical type. No. Okay, so you got so if you don't answer this question, that is simply you are not doing your job. You are not doing your homework. You are not putting effort into this program. So we got yes and no. It's called nominal. An example: yes, no. And we got ordinal. And of course, we got binary. Binary is 0 and 1. Binary is 0 and 1. And nominal is ordinal is something that is is a sequential data, or something that has a sense of ordering, like for example, bachelor degree, BS, master degree, PhD. So you cannot have a master's unless you have a bachelor's. You can have a PhD in theory until you have a master degree. So you need to know this type of, if your data is nominal, if your data is ordinal, and if your data is a binary. Why do you need to know that? Because this requires type of categorical data requires different transformation method. So if you were to get, for example, if you have a column that says, no, let's say that we have a small data set. Okay, and in data set we have only 2 columns. Okay, so we got here, let's say, customer ID and the gender, and you got 7, 21, 49, 56, 109, and you got F, M, male, F, and M. Okay, so what type of data, categorical data, is this one? Is it nominal, ordinal, or binary?
Binary.
Or
Domino.
Why do you know? Why? Someone who said binary? Why do you think it's a binary?
Because we can translate the male or female to a corresponding 0 or 1.
No, is it 0 or 1?
Yes.
Answer my question, brother. Is it a 0 or a 1? Fad.
Oh, no. It's
So
going to be
it's not
nominal.
binary. Okay, if it's a 0 or 1, yes, it's a binary. What else? Is it nominal or ordinal?
No.
Nominal.
Yes, it's nominal. Okay, how many levels do you see?
I mean, there's only male and female. There's no level, right?
No, how many levels? How many factors that you see here?
2.
2.
2.
3.
Why do you say 3? Someone who said 3. Why do you think it's 3?
Female, male, and
You got, this is 1.
yeah.
This is 2nd. This is a 3rd. M and male, they are totally 2 different animals. This is 2 different things in the data. So what we have to do first is we need to look into this consistency of your data by simply fixing this type of problems. So we need to fix this type of problem first. And so to transform this data into numeric, of course there's a lot of methods. One of them is simply applying the values. Applying values of zeros and ones. So this is a gender, and F. Let's give F a 0, M a 1, male as a 1, F is a 0, and M is a 1. Okay. So we transformed the categorical data into numeric. But the question is, what's wrong with this method? This is not the correct method. What's wrong with this method? Okay, from the ethical standpoint, let's say Selma is a sister here. She would complain, why did you give me a 0 and you give yourself a 1? So there is a type of discrimination in determining the values. And if we do 1 and 2, of course, this is another type of discrimination. If we do 1 and 0, it's still. So that is one reason this is not the correct answer, the correct transformation. Another reason why this is not the correct transformation is, remember, an algorithm is simply a mathematical function that deals with numbers. So when you feed a value 0 into the model, into the algorithm, and you feed a 1, which one you think is higher, the algorithm is going to treat with higher importance, the 0 or the 1?
1.
So the model will think, the algorithm will think that 1 is better than 1. Now if you have $1, you are worth more than someone who does not have nothing. Okay, that is another reason why this this transformation is not going to be is not the right transformation. So we need to know the type of the features, type of the categorical data they have, especially nominal or ordinal, and this would determine the best or the optimal transformation method. So this method here that we used could probably work on something that is ordinal. So bachelor's, we could give it a 0, MS 1, and PhD 2. So which is better, PhD or MS or BS?
PhD.
PhD is going to be number 1, and MS is going to be number 2, and of course bachelor is going to be number 3. So which one is better, 2 or 1 or 0?
PhD 2.
Yeah, 2 is better. So PhD is better and 2 is better. So this type of transformation only applies if your data is an ordinal, and this is called mapping. Mapping, your the values to a numeric. For nominal methods, there are a lot of techniques that we could apply, and one of them is called dummy variables. One of them is called dummy variables. Of course, there are others. There are one-hot labeling, label encoding, one-hot encoding. There are a couple of methods that you could use, but because of the the shortness of the program, the 10-week program, we are going to learn only one technique. But please don't copy me wrong. There are more than a technique that you could use to transform your categorical data into numerical data. So this dummy variable, what it does is, number one, it looks into the levels of your categorical data, and it creates a column for every single level of or factor of your categorical data. So in our case here, we got the gender, we got the F1, M2, male 3. So we are going to create 3 features. But before we do that, we are going to create 3 features. But before we do that, we got to fix. We got to fix the male things. So we got to fix this. We got to transform this into a male. Okay, and if that's going to be fixed, then we don't need this anymore. So the dummy variable will create a column, a separate column for every feature, every level of your data. So we are going to create gender underscore F and gender underscore M. So the dummy variable is simply indicates if a value is present or absent. If it's present, give it a 1. If it's an absent, give it a 0. So in the first one, do we have is an F present? No. Yes. No. Then give it a 1. And is an M present? No. Give it a 0. The second one is an M an M is the present, then F is 0, and 1 for the M. 0, 1, 1, and 0, 0, and 1. Okay. But again, what's wrong with this method? Yeah, there is something very serious. There is some serious problem with using this method. What is it?
I think still if you're doing any kind of correlation, it's going to count it as an actual number.
Salma, can you please? I barely hear you.
I said I think the numbers are still going to be used on any kind of correlation. It's still going to count the 1 is higher and 0 is lower.
No, mom. It's yeah, it will do that, but it's better. The accuracy is better than the mapping method that we learned. Okay, so Salma, if I were to ask you, what is your gender? What would you say?
A female.
So you are a female. And why you did not tell me? Why you did not tell me I am a female, I am not a male?
Because it's implied.
Here we go. So what would happen if you tell me I am a female and I am not a male? You are giving me information twice.
False. It becomes like almost like a
Redundant.
not. Yeah.
It's I mean you are duplicating the information, right?
Yes.
So when you have duplicates in your data, it creates a problem. It creates a problem. Duplicates. And the model will think about the gender as probably if we have another column that is called let's say education level. So the model will think that the gender column in general is better than the other columns because we have a duplicate information in the gender. So the dummy always apply parameters is called n minus 1. So what is n? The n is the level of factors. So how many factors do we have after we fix this? We got 2. 2 minus 1 is equal 1. So when we transformed the categorical data into numeric using the dummy, we are going to eliminate 1. So which one to eliminate? It doesn't really matter. So if you were to eliminate g underscore f and keep g underscore m or vice versa, it doesn't really matter. So it's n minus 1. So now we got column ID. The gender will be removed because it's been transformed. So we remove this, and now we got customer ID and gender underscore m. So we got 0, 1, 1, 0, and 1. So why do we need to remove again? As I said, to avoid creating some redundancy and duplicates in the data. That is the concept of applying dummy variables n minus 1. Okay, so what if you have, let's say that you have another feature that is someone does not want to reveal their gender. So we got O. You got a variable in there, or undecided. Okay, so we need to create again. How many columns you think we are going to create using the dummy variables?
2. N minus 1.
Yeah, it's going to be 2. So for this one, for the first one, it's F 1, 0, and 0. The second one is M. So 0. Yeah, it's going to be 0 for F, 0 for M, and 0 for the O, for the O. The third one is the fourth one is 0 and 0 and 1. The fourth one is going to be 1 and 0 and 0. Then we got 1 and 0 and 0. So then we're eliminating this. So, but we got 0, 0. So the output of the remaining feature is going to be 0, 0 or 1 and 0 or 0 and 1. So we got 3, 0, 0, 1, 0, 0 and 1. So we got 3 outputs that represents the original feature. So you got 4, we are going to create 4 minus 1. So as I said, you need to know the type of categorical data that you have, if is it nominal or ordinal. Knowing that such information will help you determine the optimal transformation technique. So what works for nominal might not work for binary and vice versa. And the second thing that you need to know is the level of cardinality. Imagine that you have a column that is called a column is called zip code, and you got 1,000 of zip codes in there. So mine is 30004, then 30041, no, 3009, 30028, 30014, and 300, etc. So we got 1,000. Okay, how many? If we were to use this this feature here, and this feature is very important, so we gotta use it. How many? So we got 1,000 levels. How many features we are going to create? Yeah, using the dummy variables.
999.
Yeah, 999 if we were to apply n minus 1. What do you think about this? 999 features. Come on, guys! I need some dialogue here. I need some interaction, please.
It's a bad idea. Yeah.
Why it's a bad idea?
It's just a number of dummy variables, and the computation to get the process of elimination is just not straightforward, right?
So it's not the right things to do simply because of dimensionality.
Mm.
And imagine that you have another 5 features like this in your data. So you'd be creating. We started with, in our example, we started with 1, 2, let's see, 21 features, and we are going to end up having 21,000 features. So there are a lot of problems around it. One of them is the computation again is gonna take time to compute to build a model. Number 2, it could slow the system. Number 3, it could cause what we call in data science the curse of dimensionality. Unfortunately, we are not going to cover in the program. Number 5, you could run it successfully, but trust me, you will not be able to visualize the end result, and you might not be able to interpret the end result. So it's really we cannot dummy or transform a categorical data into numeric if it has a level, if the level of cardinality is very high. So if something lower than less than 20, probably could do, but 1,000, this is too much. So what do you think we should do? What do you think we should do? In this case.
Just an idea. Could we categorize them or bin them together, group them in categories?
Can we sample them?
You could, but I'm looking for the optimal method. Yeah, there's some methods. So a zip code is a level of granularity, is detailed column, right? This is too much information. What do we think we should do if you have too much information? So we need to
Level
go
up.
level up. Yes, we need to go to the one level. What would be the next one level of zip code? The address.
Go city.
City.
Here we go. Now you're thinking, yes. Let's say ITC Alpharetta. Yeah, this is an address. I'm looking for yeah, anyway, so I don't want to go that direction, but yes, the second level probably is city. If it didn't work, then you could do what? A state. It's the same information. Of course, you are going to lose some information in there, but still, it's the same. Overall, it's the same information. So this is all Atlanta. ATL, 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 ATL.
Brother, I think also the first two digits give you the city. Like if you just take the first two digits of the zip
Yeah,
code.
it could be, yes, yeah. But I'm just giving you an example of the level of granularity, level of cardinality. If your data has is high cardinal feature, before you transform it into dummy variable, see if there is a way you can go up one level of cardinality. So in our case, we have a zip code. We could use a city. If the city is too many cities in there, we could simply use the states, etc. So this you could end up having a feature with only 3 states rather than having 1,000 zip codes. 3 states is the same information that you are going to get. No, but for the zip code, we have too much details. Okay. Any question concerns about the two things that we talked about in terms of knowing your categorical data and knowing how to transform them? Okay, I'm going to take your silence as clear. Now let's go to data. Okay, transform your data, categorical data. Of course, as I said, there are a lot of methods that we could use. So number one, we in this code here simply displayed all the features that they are not numeric, and this is the features. So we got we got the job, marital status, education, default, housing, loan, contact, month, day of the week, and per income. Yeah, previous outcome. Okay, and so hold on. Which one you think should be upsized or down? No, go one level of cardinality.
Job.
So job we have, yeah, we could do that, but we are going to create in the job how many features we are going to create. So we already have 21 feature, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Minus 10. plus, okay, how many features we are going to create in here?
12.
If we were to do dummy variables.
11.
11. Someone do the math for us, please. Plus 3, plus 8, plus 7, plus 2 for this one, plus 2 again, plus 2, plus 1, plus 9, plus 4, and plus 3. What is the value?
54.
54. So we started with 21 and we end up with 54. So I mean, if we have and we got 41,000, I think we are okay. But if you have, let's say, if you have 500 records, this is not okay. So 41,000 with 54 columns, I think we should be able to handle it. So that is this is called in data science. Please search it. Curse of dimensionality. So what is curse of dimensionality? Let's assume I'm going to talk about it in brief. Why do you need to worry about it? So let's assume that you have a small data set, a very small data set. And we got few columns in there. Okay, so we have age, and we have here income. So we got some values in there. Okay, so when we plot these two variables into 2D space, you are going to see something like this. Let's assume this is what we see. So we got here age, and we got here income. Okay, but the moment, so this is what we are going to see. If the two features were plotted, but if we were to add a third, variable in there, a third dimension, and let's say this is level of experience. We got 5, 20, 11, 7, 9, 11. With the same data you are going to get, but it's going to be the distance is going to be too large, the distance. So let's say now the distance between these two. So which one is high distance? Using the Euclidean distance. Using the Euclidean distance. Which one you think is high? Is larger? Is it the first one? So this is 2D, and this is 3D. So we added here. Let's say we added the third variable. That is experience. So which one you think is distance-wise is higher? The first, the 2D, or 3D?
I think 3D would have more distance.
Yes, and what is the problem now? What is the problem with that?
It's going to show a weaker correlation.
Probably. But when you build a model on 2D, the model is going to make an attempt to learn from the entire data set, because it's going to consider them as one. For the 3D, the model is going to try to learn, is going to treat every single element of your data as a single point cluster. So it's going to think that this is every single data point is a cluster. So instead of a model learning from the entire data set, the model is going to learn from cluster 1, cluster 2, cluster 3, etc. So the learning is going to be more complicated and more won't be accurate. So this is what we call the curse of dimensionality. Is the space is we are going to expand, we are going to fall apart, or we are going to apart the elements of your data from one another distance-wise, and the model is going to treat them as a single point clusters rather than one cluster. So that is called curse of dimensionality. So please search it up and educate yourself on that. Unfortunately, we cover this in the full program, but not in this program. So we have to have, in the rule of thumb, we have to have more records and less features. So this is the rule of thumb. We have to have less features and more records. More records will help us to build learning, and less features, it helps the computation, it helps the reduce the dimensional problems, etc. Okay, so we are going to, the 45 out of 55, 45 features out of 50,000 or 41,000, it's good. Okay, so we could do label encoding. We could do one-hot encoding. Please educate yourself on those. And now we are going to do the dummy variables. Let's take a look again. So this is all the dummy variables. This is all the features that we have. And we got 41,188 the records. And we got 21 features. And we are going to use a PD, means pandas. So we are going to use a pandas method, import pandas as PD. It's called get dummies. Excuse me. And get dummies for apply all the bank all the 21, get the dummies from all the 21, but only the 21 that has the prefix to dummy. To dummy is all features that are not numeric. So all the features that are not numerical, exclude numerical. So we are not going to create a dummies for numerical data, only non-numerical data. And we got drop first equal true. Can anyone explain what this drop first equal true?
So the number of features take
What is
one
drop?
less.
Explain this. What is drop underscore first equal true? Is n minus 1.
So
The first-
anything.
Yes.
Go ahead.
Yeah, n minus 1. So here we go. Let's take a look and now go 45. Yeah, I did this. So now we got, let's say, for example, for a job. So we got job underscore solar, job underscore entrepreneur, housemaid, and then we got education. We got here marital status, married, single, unknown, education again. So we got a lot of zeros in there, which is beautiful. Okay, so we don't have any categorical data anymore. And now, so, but still 45 probably Probably all these 45 might not be all what we need. So what do you think we should do next after we transforming the data from categorical to numeric? What do you think we should do next? Is find out which features are important, right? That is called feature selections, and we got it here in red. Why it's in red? Because it's important feature. Feature selections, feature engineering, they are very important. Okay, what do you think we should do to determine if a feature is important or not important? We already learned two methods in the past. What are they?
Prior knowledge and
Prior knowledge and
correlation or constant value.
correlation analysis. Yes, sir.
But I thought we already did that before we come to this point.
Yes, we already did it, but we can do it again.
Okay.
But unfortunately, none of this is going to work. Prior knowledge, we are done, so we don't have anything left that probably could cause a problem. We don't have any personal detail columns, any ID columns, any constant columns. And correlation, do you think is going to work or not going to work? If we were to find the correlation between all these features and our target variable.
No, because they are 0 and 1, correct?
So why do you say why? Who cares about 0 and 1? So
would it give you the same correlation?
So what are in the correlation? What are the conditions of correlation analysis?
Anything close to 0, we keep it.
No, sir. Yeah,
anything close to 0 or 1, we remove those.
No, I mean you are thinking about something else. I'm not asking about that. In the correlation, we are looking for the relationship between x, and the relationship between x and y. So for the x and x, we are going to keep anything that is not equal. That is not closer to 1. And from x and y, we are going to keep anything
-1 and 1
that is not equal to 0. And the correlation always going to be between -1 and 1. Okay, but to get a better accuracy, we have to have some conditions. Correlation has some conditions. There are 4 conditions that we learned in the past. Salma, I know you had something.
Yeah, I wasn't sure, but I think it's I think it has to be linear, the data or something.
Linear. Okay, what else?
I'm not sure if it had to be numeric or not. I think because we changed.
Yes, numeric.
Must be PX.
Say again.
Sorry, I don't remember anymore.
Okay, linear.
Someone else is on.
Numeric, real values, and pair. So which one out of these 4 here is not is not met? So there's one serious condition that we did not meet in this 4. Is the real. So
yeah, zeros.
Have real values. So the zeros here and ones, they are not real. They are transformed values. So correlation is not going to be an option either. So now we have to go to more advanced technique on determining the importance of these features. And to do that, there is a lot of methods. So we could use feature important method using machine learning. This is what we are going to use. We could use sequential feature selection. Yeah, so I'm going to share this. Please explore it. It's a package. It's a ML extent. Yeah, ML extent is similar to scikit-learn. Please go ahead and explore this. I'm going to share the link in the chat. Okay, so just copy paste, and but it's a very important package to help you determine the importance of the features. Okay, we could do yeah, I have some codes in there, but I'm not going to random. Yeah, we could do feature identify features with low variance. We could identify features with PCA, feature extraction with recursive feature elimination, feature extractions with univariate statistical test for categorical. Then we could remove collinear features, remove correlated features, remove constant features, remove duplicate features, remove correlated features, and finally we are going to save as version number 3. So one of the we are not going to learn all these methods, but it's you got the template. Play around it. Schedule one-to-one session with me if you have any concern, any doubt. But the one we are going to use today is machine learning. So for machine learning, unfortunately, I'm not going to explain this with much more details at this point of time because we are going to cover it next week. But for machine learning to work, we need to identify X and Y. So X is all input, all inputs, and the Y is the target variable. So we are going to identify here X is everything is the 45 features except one feature, that is the term deposit. The term deposit is our target variable, and the Y is the term deposit. Okay, so if you look into the X shape is 41,198 and 53 because we removed, and for the Y shape is going to be one column, 41,188. Okay, so we need to identify X and Y, and after that we need to split this 41,188 into two data sets, into two partitions. So we have, yeah, this is our 100% data, which is going to be in our case 41,188 records. So we are going to split them randomly into 80% and 20%. 20% is called a training set, and the 20% is called testing set. And training set, this is the set where we'll try to learn, we'll try to apply a model, apply an algorithm to learn something, learn a pattern, learn a signal, learn a relationship. And whatever we learn from 80%, we are going to test it on the 20%. And if we are happy with the performance, then we can share the model with the management to deploy into the production. So we cannot build a model and deploy it into production without testing its accuracy. That's why we have to split into 80%, 20%. So this code will split. I'm not going to talk about the code because we are going to cover it next week.
Mo, I have a question.
Yes, sir.
When you split 80-20, do you split only one time or you once you get this training set, you develop a model, you test on 20%. Do you split again and try to test the model? Because one time you split, you might have got some pattern. Maybe if you split again randomly, you might get different data
So
set.
yes, it's one time, and yeah, you could run it as many times as many. You could run this code as many times as possible, but you set a random state. A random state simply means when you split again, you are going to get the same members of 80% and the same members of 20%. Let's say that this is you. Okay, this is you. So when we split, you went the first split. You went with 80% because this is random.
Okay.
There is a chance you are going to be in 80%, and there is a chance you are going to be in 20% if we were to do it again. So to secure that you're always going to be in 80%, we are going to set, it's called random state. We are going to random underscore state equal a value. So we have to have a 45, for example. So these parameters here assures that all the elements that were picked for 80% the first time is going to be for the second time you split, the third time, the fourth time, etc.
Okay, so if we change the seed, then we might get the data set in 80% will change.
If you don't specify this, the seed, so every time you are going to get a different 80%. It is going to be 80%, 20%, but the values that were randomly picked for 80%, 20% will always be different every time that you run this. So we'll talk about this in the next week.
Okay.
So we split. Okay, and please don't ask me how this is working because we are going to talk about it next week. So we are going to build a model called the XGBoost classifier. Okay. So simply, we are going to build a model to determine. We are going to build a model to determine. We are not trying to predict. Now we're building a model here not to predict, but to determine how the model used all these 43 to determine the value of the target variable. And here we go. So as you see in this bar chart, or some models, so this is all the features here. They are 53. 53. Some of them, they are very, very important. Some of them, they have a 0 importance. Okay, if we were to build, if we were to use 1, 2, 3, 4, and 5, 6, 7 out of 53, we could still get a better performance. So now let's find out, how important. So the best, some of the features here, they have a 0. No, so marital unknown, loan unknown, default yes, and previous outcome non-existence is 0. Probably we are going to remove this, and we could remove others. And the highest or the most important feature is number of employed, duration, etc. So we could simply keep this is number of employed. This one is the number of employed, and duration. This is the duration, and conf ID, probably this one. But anyway, we could keep 1, 2, 3, 4, 5, 6, 7, and 8. 8 features. 1, 2, 3, 4, 5, 6, 7, 8. We could keep only these features out of 53, and we could get a better. We could get a better. We could get a better prediction. Okay. So this all the features not equal to 0, but I said we could we could eliminate most of this. So let's do that. No, I'm going to simply
So is that in descending order?
yes,
Okay.
let's keep only 1, 2, 3, 4, 5, 6, 7, and 8. Okay, let's keep this for now because simply all I'm doing here is exploring. And of course we are going to need our target variable, which is term deposit. I'm not explaining what the codes, which we'll talk about next week. Okay, so now I'm going to override my data with only the most important features. Okay, and I am going to use this data here to build a model again. Okay, and now I'm going to look into the columns. It's only 1, 2, 3, 4, 5, 6, 7, 8, and the target variable. Then I'm going to identify X and Y again. Okay, and now I'm going to split my data again. Then I'm going to run my model. And here we go. So now we got the features. And here we go. So we got 44 again. And we still have some low influence, low importance, but that is better. Building a model with 7 high important features is better than building a model with 53 features. Some of them we don't have any impact. So we explored feature selections using a machine learning method. Of course, you could do the same if you were to do sequential feature selection. Please run this and just run this and just run it and leave it for a month because it's going to take a time. And at the end, we are going to save as version 3. But I am not going to do that because I really don't want to reduce any dimensionality at this point of time. This is too much. So we could simply eliminate the last 4 ones. Probably 1, 2, 3, 4, and 5. So we could keep all these features in here. Okay, so let me run my data one more time. So I need to start over from the beginning. Yeah, I could do up to here. So I'm going to go cell run all above. Okay, and how many features that we have? Okay, so we got our, there we go. Now we can split the data, look into the importance. And we are going to eliminate 1, 2, 3, and 4. So we are going to eliminate, we are going to keep only these features. And let's do that. Okay, and I'm going to override my data. We could do to delete. We could do that. And let's run it again. Take a look into the columns. 49. So here we go. And split the data. Run the model again. And let's take a look. Yeah, so we got a few variables in there. They have minimum, 0.0029. So we could eliminate anything with two zeros. Anything with two zeros, for example. Two zeros, two zeros, two zeros. Yeah, we could start from here. We could keep anything from here. Yeah, from four. So it could be all these features. So it's totally up to you. So now what you gotta do here is saving the file as version number 3. There we go. And let's take a look into version number 3. So date, here we got version number 3. So now this is the version of the data we are going to use for the modeling. So we are done. So all what we did here is we transform the data into numeric. We reduce the dimensionality of the data by using feature importance. And there is one last step that we have to apply to this data here, and we should be really good to go. What is it? Okay, $100. If you know it, we already talked about it. It's $100 gift. Okay, what is it?
Eliminate duplicates or anything like that?
No.
Did you do feature selection? No.
We already did.
We can work on the data precision for all columns.
Say it again?
Maybe same data precisions.
I barely hear you, Idris. I think you getting it right. But I mean, can you repeat?
I think we can work on the same data precisions, maybe 2 to 2 decimal places for all, or to.
No, sir. No, sir.
Okay. Remove the index values.
Idris, you are in the right direction. Idris, you are in the right direction. So what did we talk about? What did we say about applying? What did we say if we were to use mapping? If we were to give an F of 1 and M of 0, what's going to happen?
You have to delete the extra redundant column.
No, forget about this. Forget about this. So think about only we were to map. We get an F of 1 and an M of 0. What is going to happen?
It's going to treat F as a higher number.
Yes. And what do you think about this data? Which one will be treated higher with high importance?
One.
The one with 1.
B will be treated high importance. This is number 1. This is number 2. This is number 2. This is number 3. This is number 4, number 5, number 6, and the remaining. So what do you think we should do to avoid having larger numbers dominating over small numbers?
We need to scale them down.
Yes, sir. It's called scaling. So we need to scale them. And for the scaling, it could be put them all between 0 and 1, or minus 1 and 1, or minus 3 and 3, yeah, etc. So we need to scale them, which we are going to do next week. Okay, folks, so that's it for today. We covered most of the important features in transforming your data from categorical to numeric. We dealt with missing values, outliers, duplicates. We dealt with transforming the skewness. We learned how to visualize the data. We learned how to a lot of concepts to give us or grasp some make sense of the values of the data, etc. Now we have a better version number 3. It's better than 2, better than 1, better than raw data. And this is the version we are going to use for next week into machine learning. So next week we are going to build systems that take this data and learn the patterns from it, learn a function, learn a mapping, learn something out of it. And whatever we learn from this data using machine learning is what we are going to apply for any future clients joining the business. So before I dismiss you, any concern, any doubt, any question?
So Mo, I have a question. When you said scaling, is it also called normalization or scaling and normalizing?
Yeah, it's called, it depends, Okay. Yeah. So it's called, you could use any of these methods.
Okay.
Yeah, maybe, good question.
Okay.
Yeah, min-man scalar, you could use this one. You could use standardize, 0. You could use normalize.
Okay.
You could use scale, is data scaling. So this is, and as a matter of fact, this should, I think this should come after. Yeah. So this is the wrong. Let's remove that. So this is not the right position.
Okay.
Yeah, but yeah, let me remove this. I'm moving this all the way down. So this is the wrong. Yes, after feature selection, so it should be all the way before you save your data. Yeah, this is the last. After you remove features, this should be just before you save your data. But I mean, we are going to use it with the machine learning. Okay. So
yeah.
Now we got here. We removed all the features. Now we scale and we save. If we want to scale this data, let's say they use let's see if we can use. Yeah, I mean, I don't have the code. I don't think this is the right code. But anyway, we have a method. Yeah, we have a method to scale your data, which we are going to do next week. And next week, we are going to jump into machine learning, but we are going to scale our data to avoid the problem of dominating. Now, of course, we want the model to treat every single animal, every single feature of your data here with the same importance, So if we were to keep the values different, of course, the model, which is simply a mathematical function, will think that number of employers is better than any other zeros and ones, because this has largest values. Okay, folks, that's it for today. I'll talk to you next week. Until then, you guys have a great evening, a great rest of the week. Bye, everybody.
Thanks, Mo.
Yeah.
Thank you very much.
You are welcome.
Bye.
Thank you so much, Mo. Appreciate it.
You are welcome.